me, but I know he's going to actually catch me, or like does it when I know I can catch me. You literally try to trip me in the hole.
All right, we're going to learn a technique for solving differential equations today. Everything that we've been doing with integrating is solving differential equations. What we're going to learn today is when the initial problems are a little bit more complicated when we look at them, okay? So, the technique is called solve by separating variables. What does that make you think? We're going to separate things. We're going to get everything that's got a y in it on one side and everything that's got an x in it on the other side. Okay? So here's our first problem. dy over dx equals 6 minus x.
It's not the first problem.
We do? Well, what's the first problem? Oh, 2x over y. Okay. Okay, so we've got y prime equals 2x over y. Now, I think it will be easier for you if you will always change any of your derivatives to dy over dx. So I'm going to make this dy over dx equals 2x over y. Now, in addition to that, don't think of this as a quantity. Don't think of this as dy over dx. Think of it as a fraction. So when we say we want to separate our variables, we're going to get our y over here with dy and make it y dy. We're going to get our dx over here with my 2x and getting it 2x dx. So we've changed this problem from the two fractions to y over dy equals x over dx, equals 2x dx. Now, if we want to solve this, we need to integrate it. So we're going to integrate both sides. Because as we've discovered, when we integrate the left side, what's going to happen to dy when we integrate? It goes away, okay? So when we integrate the left side, what do we get? Y squared over 2 plus c. Okay? What do we get on the left side? On the right side? X squared plus c. And I'm going to put numbers by them because there are really two different c's there. Now, is it necessary to have both c's there? Because really, if I were to bring this c over here, I could subtract it from that one because they're both constant numbers, right? So normally you would not see it written with two c values there. Normally you would see maybe this written, y squared over 2 equals x squared plus a capital C. Another way this answer could be written, because the fraction just scares some people to death, right? So what if we multiplied everything by 2? We'd have y squared equals 2x squared. Now I'm just going to leave it as c. Why did I do that? This c right here is not the same number as this one up here, because I just multiplied through by 2, but it's still a constant number. Remember, capital C just stands for a constant number. We don't know what it is, we don't really care. So there's no reason to write the 2c there, it's just a c. Okay? So what you can glean from this is integrate both sides. When you get your problem like you want it to look, put a c somewhere. Okay? Add c somewhere. That'll solve it for you, okay?
May I ask a question?
Yes, you may.
How do we want it?
I would suggest that you want it looking like this last line here, because that doesn't have any fractions, makes it nice, neat, it looks, we're comfortable with that there. Okay?
May I have a question?
Yes, ma'am.
Why do you integrate?
Why do you integrate? Because we're trying to solve this differential equation. We're trying to figure out what is y and what is x, not what is the derivative equal to. This is an equation that we can manipulate in some form or fashion that's not a differential equation. We're working backwards with it. When we get to applications next week, I think it'll make a little bit more sense because we'll have the rate of change of something and we need to know what formula gives us that rate of change. Okay, so let's move to the next one then. dy over dx equals 6 minus x. So, let's get the dx over there. So yes, we'll have dy equals 6 minus x dx. And now we're going to integrate. Well, what happens on the left when we integrate?
You get y.
We get y. How do we know it's y?
Because there's an imaginary 1 there.
There's an imaginary 1. But how do we know it's not x or k or theta?
In respect to y.
Because it's a dy. So we know that we'll have a y on the left. And when we integrate over here, we get
6x minus x squared over 2 plus 2.
And you could multiply that through by 2 if you wanted to. I would say this one would normally stay like that. Why do you think that one would probably stay with a fraction?
You have to have y over 2.
Then we just got y by itself. That's easy to solve. If I tell you x is 5, you can plug it in there and poof, get an answer out real easy. So there's no set way for them to look most of the time. All right, let's move to the next one. It's the same problem, isn't it? It's y. So tell me what we're going to do here.
We're going to do 1 over dx equals 6 minus y over dy.
Okay. She's got 1 over dx equals 6 minus y over dy. And algebraically, we can do that.
Wait, why don't we just cross multiply?
All right, let's talk about why this is not a good thing to do that I've just got written up here. When we integrate, dx is not in the denominator. So we can't do this. We never want dx in denominator or dy as far as that goes.
Oh, so would you cross multiply and then divide by 6 minus y?
Right, so if we cross multiply, we get dy equals 6 minus y dx. Remember, this 6 minus y is a quantity altogether, okay? So we can't just divide by the y. We've got to divide by 6 minus y. Okay? So we get 1 over 6 minus y dy equals 1 dx, right?
Wait, why didn't you just go ahead and integrate?
Now we can integrate
Why didn't you integrate?
because we've got a y with a dx. We can't integrate right here because remember, we've got to separate the variables. We've got to get everything with y's on the left, everything with x's and dx's on the right. Well, what's going to happen over there with that 1 over 6 minus y? How do we integrate that? You do. U equals 6 minus y. So du is negative dy. So negative do equals dy. So we've got the negative integral of 1 over u du. We can go ahead and integrate the right side. What's it going to become? X. Well, what's going to happen over here?
It's going to turn to negative ln 6 minus y. After x is y.
Yep.
Plus c.
Negative ln, absolute value of 6 minus y equals x. This is an important problem for you because most diffie-qs we deal with are going to have ln's in them. And we don't want them. So solve this for y.
Put an a in something.
Can you subtract c first?
You could, but I wouldn't.
Wait. What did
I just put plus c over here, away from the ln's confusing enough for me right now. I don't want to add anything to it.
So you don't have to like subtract it. You can just say.
Yeah.
Use ln. I mean, E's.
E's. All right, so tell me what you mean by that.
Put E's on both sides.
Okay, so we're going to say e to this power and e to this power. Or we're going to think of it as a definition. E to this power over here, x plus c, equals absolute value of 6 minus y, right? Now what do we do with that minus sign? Where'd that minus sign go to, you think?
Wouldn't it be negative?
No, wouldn't it be
Oh,
negative?
no, to the x plus c.
Wouldn't it be negative absolute value of 6 minus y? Like whatever it
To
comes out
the-
to be, it's going to be negative.
To the 6 minus y. So it's negative 1 power.
1 over.
1 over 6. This is very confusing right now, isn't it? Okay, so let's back up one step and do something different to begin with. Get rid of the negative sign over there. So let's change it into ln absolute value of 6 minus y equals negative x minus c. Okay? Because we can do that, can't we? Now it becomes a little easier to deal with. Because now it's e to the negative x minus c equals the absolute value of 6 minus y. Right? Okay, and now we've got a problem that we can deal with there.
So that would be the answer.
We want to get y by itself. I'm not going to explain why, but I'm just going to say, poof, let's forget about the absolute values for a moment so we can solve this thing for y. And we'll get e to the negative x minus c equals 6 minus y. So that means e to the negative x minus c equals, minus 6 equals negative y. Means y equals e to the negative x minus c negative e to the negative x minus c plus 6. Right? Okay. Now, and I want you to just watch for a second and see if you agree with me here. Is there a different way to write e to the negative x and e to the negative x minus c? There is. We could write that as e to the negative x times e to the negative c plus 6. Well, c is what? So e to a constant number is a constant number, right? So the normal way you would see this written then would be negative c e to the negative x plus 6. Negative c e to the negative x plus 6. And if you had just had c written there without the negative, it could be just as correct. Because a negative number, it's a negative constant or it's a positive constant. Well, if you say c is 4, I could rewrite this and say c is negative 4 and get the same answer. So the negative sign might or might not be there. But a c e to the negative x. This is how you expect most of your, I have no idea what I'm doing there. This is what you expect most of your solutions with diffie-qs to look like. Something like that. Something like that. That's the normal process that we're going to be going through here. Okay? Let's go look at another one then. Y prime equals root x over 7y. Solve this on your own, please. See if you can do this on your own. we comfortable with that?
Yeah, that's what I did, and then I kept going. So you just stop.
Well, what else did you do?
I like multiply by 2.
Okay, I'm going to actually multiply by 6 and get 21y squared equals 4x to the 3/2 plus c. That would be, either of those answers would be acceptable. You need to be able to recognize both of those as a possible answer for a multiple guess scenario.
Wait, where'd you get 21?
Okay, if I multiply everything by 6 here, all right, 2 will go into 6 3 times. 3 times 7 is 21. 3 will go into 6 2 times. 2 times 2 is 4.
If you multiply by 2 everything and then multiply by the 3 and everything to get rid of it.
You should get to the same thing, yeah. Should get to the same thing. So, normally we're either going to solve it for y, it's going to have e's in it, or we're going to try to get it with no fraction, something like that. Okay? Any questions so far?
And it's hard. No, I'm just saying this one's gonna
Yeah.
something.
Solve by separating variables. Y prime equals x parentheses 1 plus y. What's your first instinct say? Distribute, don't distribute. Okay? Because that's my first instinct. I see a parentheses, distribute that puppy. Okay? But remember, what are we trying to do? Separate variables. The x and y aren't on different sides right now, but they are separated on the same side. If we multiply through, we're mixing the x's and y's together. So, we want to cross multiply first and then divide or whatever. Remember, get all your y's on the left side with dy. Get all your x's on the right side with dx. Solve this one for y. I want my answer to be y equals something. Oh, yeah. That's where I separated to. 1 over 1 plus y dy equals x dx. So I haven't integrated yet, but that's where I'm at. Any questions about what I've done so far? Keep going and see how far you can get before I have to.
I was trying to get rid of it. It kept saying invalid password, and then it popped up and said something about 2008 on it. So I don't know what's going on with this thing.
Is that how it normally looks? No. That's an old version of it.
Alright, because you separated it into that, yeah. Is that weird? Do we have to do that? Yeah. Are you sure?
Right? Oh, sitting right there in the middle of the page where I
That's
can't
why
see
I
it.
got it over there.
But yes, that's right.
That's what I keep saying. With that other thing that's going on.
Oh, that's why. Caps lock is on.
Oh, thank you. Dummy me. I was doing that chart.
See if it works with that. So if I integrate that, I get. At printsab.org. When you integrate, I got ln of 1 plus y, absolute value, equals x squared over 2 plus c. And now we'll get e to the x squared over 2 plus c equals 1 plus y. So y equals, I'm going to move my c down now, c e to the x squared over 2 minus 1. Because this right here, right, could be rewritten like this. Account locked. Okay, I can unlock that. Let me log in on mine over here and unlock it. That'll be easier for you. Okay, was that a hard process, class? All right, jump to the next one and see what you can do then.
The next one's fine. But
It is?
to a point, I just don't know how to simplify math.
Okay. All right, hold on. We're going to do something else first. Okay, now we're going to... Now try it. Are you okay with that, Elaine?
Yes.
Any questions? How did I get to this? All right. You were right here just fine. We can write this as e to the x squared times e to the c. Right?
Yes.
So we're just going to rename this number here as our capital C down here. Just makes it easier to deal with. And with the application problems we're about to get to, this is the normal place that we would see that. So that's how I got from here to here. Okay. xy plus y prime equals 100x. That looks challenging.
It's really not.
Yeah. So,
I did it right. Unfortunately,
what'd you do first then, Samuel?
I moved x, y over.
Okay.
And then I changed, in the same thing, I made y prime dy dx. Do that.
All right. Very good.
And then I cross multiplied the dx, and so it's dy equals 100x minus xy. Parentheses dx. Then you factor out an x. And then you divide dy by 100 times y. So then you do on the left and get to ln 100 minus y equals x squared over 2. Get the negative.
Okay.
Wait,
Then you put in e's.
wait, why'd you do L in?
Yeah, because it's.
Because it's you do. Just 1 over. I've done something wrong.
Oh, I forgot to put 1 over that.
Because you've got to divide by the 100 minus y to get it to the other side.
And then you introduce e's and blah, blah, blah.
Or we'll divide by negative 1.
Yeah, let's divide by the negative 1 and make it ln 100 minus y equals negative x squared over 2. So we get e to the negative x squared over 2 equals 100 minus y.
And then what you see into.
Yes.
Plus 100. Plus 100.
Yeah. I'm trying to get all my signs squared away.
That would be a negative c.
Yeah.
At least that's what
Yeah, because that moved over, so that moved. Yeah. Negative c e to the negative x squared over 2 plus 100.
I got.
Y'all okay with that? This is the type thing that you're going to see a lot of these types of answers as you deal with diffie-Qs.
Why is it plus 100 not?
All right. I moved this over here, so I moved that over here. So it's a negative in front of the e squared.
No.
Are you with us to here? All right. Then we divided both sides by negative. So the x squared over 2 became negative. Then we said e to this power, e to the negative x squared over 2 equals 100 minus y. Now if we're going to solve for y, it's a negative in front of the y. So even if you take the 100 over, you've got to divide through by negative to make it a positive y there. So y equals negative c e to the negative x squared over 2 plus 100. And I would say just be very careful with this negative sign here with the c. Right now, if you just put a c e to the negative x squared over 2 plus 100, I could not count it wrong. Because you could say, well, my c is negative and yours is positive. So I couldn't count it wrong. But just be careful, because as we get to application problems, that's going to make a big difference in what we're doing there. Huh?
Why is there a C?
All right, because technically,
Oh, no, sorry. Why
Yep.
there is a negative?
because all right, I'm looking at this problem right here. If I'm going to solve it for y, I'm going to take the y to the other side. That's how I get pod. So this becomes negative over here. Now, depends on when you introduce your c. See, technically we should have had a plus c right here, which would have put a plus c right here, which would mean it was minus when you came over there. So just be careful with that, okay? And I'm sorry, that's all I have for the day. You have plenty to work on.